Hey everybody, we're going to go over a NIMO problem that I couldn't find the answer to. I think this stands for National Internet Math Olympiad or something like that. I believe a gentleman by the name of David Altzio did this along with Evan Chin, and this was a 2018 problem apparently, but I don't think it exists anymore, that entity. Okay, but anyway, here we have an interesting problem that we have a 100-term positive integer sequence, and we're given the sum of a subsequence that is indexed by squares, perfect squares. As it turns out, I'm not sure how important that is. It turns out to be fairly straightforward just to find D. And they want us to find the 50th term, but we could, after we're done, we could find all the terms. All right. So let's get busy on this. Yeah, the primary result we're going to use is that any term in the sequence is an easy to compute thing based on the definition of a arithmetic sequence. The nth term is just equal to the first term, and we'll call that a sub 1. My a's have withstood a lot of criticism, folks, but that is a lowercase a. All right, and then since we need to start adding multiples of the common difference, we'll call that d. This is equal to n minus 1 times d. And that's very easy to see. It follows immediately from the definition of an arithmetic sequence, which is just a bunch of terms that are separated by a common difference, and we're calling that d. Okay, now let's carry on here. So we're given this information, and this is just recopied from right here, this given information. And if you collect like terms and appeal to this result a few times, you end up with all of this. And you guys can verify the arithmetic. I won't slow you down by going through that. Now we caught a little bit of a break here because we're trying to, we can divide by 5. Everything inside is divisible by 5. And so what we get right here is a sub 1, let's see, times 2 when we divide by 5. And this is plus 5 times 75 is 375, isn't it? So we have 75d here. And then we divide through by 5 right here, we get 200. Now, this is a very powerful statement already. At first I go, wait a minute, what do we really do here? Because I was thinking, oh, we need another equation. But we really can't get another equation that's useful in terms of these two unknowns that I could see. But one thing we can notice, this is a strictly increasing positive, distinct terms, positive integers, right? And so you see, we can already eliminate. We know that D's not equal to 0, right? Certainly D, and in fact, D can't be anything odd, right? Because you'd have an odd number plus this even number, which cannot be the even number 200. So D does not equal to 1 or any other odd number. Now notice, I'll skip ahead. Even if you try D, and you can't try 3 because 3 is an odd number, right? But look, D equals 4 is already too big, right? That's water in Tagalog. 4 times 75 is 300. Okay, 4 times 75 is 300. So owing to the fact that D must be even, D even, let me write this, D even okay, and the fact that you can't go any, 4 certainly doesn't work, that implies that D must equal to 2, right? So I don't know if the guys who created this problem meant this. It wasn't particularly difficult just to find D. So I don't know what was special about the finding a sub 50 up here. They want us to find a sub 50. But anyway, a sub 50 would be the first term plus, what do we got? N is 2, or no, N is 50, sorry, plus, okay, 49, right? 49 times 2. Okay. But notice that we can quickly see that from right here, if D is equal to 2, that would force A sub 1 to be 25. Okay, so what we get right here is 25 plus 98. And the mental math here is very straightforward. Side's equal to 123. So again, this seems easier than common problems that I've seen David Altzio do. You know, maybe it's, I don't know if it's a high school competition or whatever it was. But let me know if I'm overlooking something stupid. But, you know, we know the common differences too. And as far as I can tell, unless I'm just having an egregious brain fart here. But anyway, this is the answer to the problem. And again, the whole sequence has been determined just by the fact we know the common difference in the first term. Okay, the first term, a1, is equal to 25. Okay. Okay, folks, and again, that was obtained from right there. So anyway, that does it, folks. 123 right here.